Hi everyone, I am Shenchong Yu from Nanjing University. It is my great honor to have the chance to present our paper in ICSI 2021 here. The work is about the layout and image recognition driving cross-platform automated mobile testing. My presentation is divided into 4 parts: the introduction and background, the methodology in detail, the experiment for approach evaluation, and the conclusion part. With the rapid development of mobile internet, mobile apps need to fit in much more complex environment. Because there are dramatically growing kinds of different operating systems and platforms to support mobile apps. Moreover, in order to cater to market, mobile phone manufacturers develop hundreds of thousands of different models. Also, mobile apps in general include their mobile web version and some other hybrid versions. For example, in China, WeChat is quite popular and it integrates many mainstream mobile apps. Therefore, mobile apps have very severe fragmentation problem. In such a situation, mobile app testing becomes very hard. Developers have to write different scripts and use different assistant tools to do this test work on different platforms, which causes a high bar and a heavy burden for developers. Now, I will give you a vivid example. This is a very popular online shopping application, Jingdong. The layout is complex, but on different platforms, they are almost the same. The first part is a search bar. The second part is an advertisement image. The third part is a set of commodity category. The following part is a series of promotion information. And the final part is navigation toolbar, which contains same contents. The highly similar layout inspired us to automate the test work by the image and layout of the mobile application GUI. Based on the above information, we present a novel approach, LYRIT, which is the layout and image recognition driving cross-platform automated mobile testing. This page presents the general framework of LYRIT. The whole framework includes the following contents. First, a platform-independent test script model based on the image and layout analysis, LITS. Second, the test script recording based on the GUI screenshot layout characterization and widget extraction, and the test script replaying based on the widget feature matching and the layout characterization matching. Existing mobile app test scripts rely heavily on the underlying operating system interface support, making it impossible for the scripts to replay on different platforms. To realize the cross-platform record and replay, we extract the image information and compose the platform-independent test script. The test script model includes the app activity screenshot, the widget screenshot, the relative widget coordinate, the operated point coordinate, and some other information. Such information can work together to help complete the test script record and replay. App developers need only to operate the apps as end users, and the recording of the information is completely automatic. During the test script replaying, we adopt 2 strategies: the widget feature matching and the layout characterization matching. Widget feature matching is also adopted by some GUI-based record and replay tools, like Schooling. The first phase is the respective processing of the recorded target widget image and the replay device activity screenshot, including processing, feature detection and describing, and the feature point set construction. Then, the 2 feature point sets are matched, and the extra mismatch elimination is also conducted to improve the matching accuracy. Then, the coordinates of the matching area is obtained. Specifically, the safety algorithm is used in our implementation, though other similar algorithms are replaceable. Layout characterization matching is the main contribution of this paper. One thing to highlight is that one limitation of LYRIT is that we only focus on apps of the table or grid-based layout, so apps like video games are beyond our reach. Since the layouts are table or grid-based, this means the widgets are almost well arranged. Therefore, we first identify all the widgets with the edge detection, and this procedure is assisted with the text detection. With all widgets identified, we can further characterize the GUI screenshot layout. With the given example, we give a detailed layout characterizing process. First, we execute group operation, which means a rough horizontal characterization to the screenshot. Widgets wrapped in other widgets are omitted in this step, and we will get several groups of the widgets. Then we divide each grouped into several lines by line operation. In the line operation, some widgets that wrapping other widgets will be segmented according to the counters of the wrapped widgets. Finally, in each line, we execute the column operation to segment each line into several columns vertically. Some subtle merging operations are also executed to remove noise layout. The results from the widget feature matching and the layout characterization matching are merged to determine the final target widget on the replay device. We also conduct an experiment to evaluate the layout. In the experiment, we totally collect 21 mobile apps. The apps include commercial ones and open-sourced ones, and cover 10 different categories, which can show the generalization capability. The selection is according to the ranking of Google Play, and apps are filtered by the criteria of multiple platform supporting. We also use multiple experimental devices for the experiment, including Android platform and iOS platform. Our experiment covers most mainstream mobile brands and models, including Samsung, Huawei, Apple, Oppo, Vivo, and Xiaomi. And the devices are of different operating system versions and different screen resolutions. We in total set 3 research questions. The first is the script replay accuracy. To answer RQ1, we recruit 4 senior students in software engineering to organize 105 test scenarios on experimental mobile apps, and record the test scenarios on an Android device. The average replay accuracy of Android and iOS devices are around 65.85% and 35.26% respectively. Though the absolute number is not very high, but this work is groundbreaking for cross-platform record and replay. In RQ2, we compare Lyrit with Skuli, which merely uses the widget feature matching. Skuli is the state-of-the-art GUI-based record and replay tool. We can find that our framework has an improvement with layout characterization matching over the state-of-the-art approaches by 8.74% and 35% on Android and iOS platform respectively. The improvements are especially obvious on cross-platform test script replay. We also review and analyze the failure cases one by one and summarize some failure reasons. In the widget feature matching, failures due to repeated highly similar widgets account for almost 1/3 of all failure cases, which is the most important reason for failure. Secondly, the parsing failures in the recording phase result in the wrong screenshot of the target widgets. Such failures account for approximately 20% of all the failure cases. Some minor reasons also have led to individual failure cases, such as the missing of corresponding widgets on the replay device, too few feature points extracted by the algorithm, making the algorithm output results set empty. In the layout characterization matching, 63% failures cases are caused by layout characterization errors. Subtle layout changes caused by the change in the activity contents cause approximately 16.3% of the failures. In addition, about 12.1% of the failures are due to the change in the device status bar. Therefore, there is much space for improvement in layout characterization, and our approach will perform much better if the layout characterization algorithms has improvement. Finally, we make the conclusion to this paper. First, we propose an image-driven record and replay testing framework. Second, we introduce a platform-independent test script model to support the script record and replay. Third, the novel cross-platform widget matching approach with layout characterization has an advantage over the state-of-the-art tools. Finally, we experiment on real apps and devices to prove the effectiveness of Lyrit. Thank you for listening to my presentation. You are welcome to ask any question about our work.
Hi everyone, welcome back to this Q&A session for the paper titled Layout and Image Recognition Driving Cross-Platform Automated Mobile Testing. We have the pleasure to have Sheng Yu with us here in the Q&A session, and he'll be very happy to take any questions you might have. So please write your questions in the chat panel. Shen, can we check your audio because you were having some issues?
Can you hear me?
Yes, we can hear you. We can hear you.
Thank you.
Perhaps I can start the Q&A by asking you, in your approach architecture, you described that your widget feature matching algorithm, you've used one, but any other algorithm could be used instead, right? You kind of said that your approach is parametric with respect to the widget matching algorithm. Could you please give a little bit more insights on what kind of other algorithms you could use instead of the one that you have implemented?
We use the SIFT algorithm in our implementation, and some other algorithm like ORB and SURF and so on can be used. And we take the SIFT algorithm because during our early stage examination, early stage experiment, we find that the SIFT is most suitable for the mobile app image understanding scenario. We did not have we did not have some further experiments, and we think the adoption of the algorithms is only part of the tool implementation, and it will not greatly affect the approach design.
Thank you very much. I have a question that Chanduk shares with me. In the results that you have presented, it's clear that your success rate is much higher for Android than for iOS. Do you have more insights, or do you have any conjectures about why this is the case? And Chanduk expands this question further and asks, did you consider comparing with test script repair techniques?
The performance on iOS devices is not so well as the performance on the Android devices, and because there are some slight differences on the screen layout. For example, Android and iOS provide different mechanisms for the app designs. They have different design rules for developers to obey. So the rules may lead to some different layout designs to the app, and our approaches rely on the app layout, rely on the activity layout. So the design rules of the platform can somehow affect the effectiveness, and to the script repair technique, our approach is record and replay approach, and it is good to script repair process before the replay, but in this approach design, we did not consider the script repair, but this is a very valuable suggestion, and we will consider to add the repair technique to the extended version of this work.
Thank you very much. Yes, that's a very nice idea, actually. Could you please elaborate a little bit more on the experiment that you conducted when you asked humans to evaluate the success of the technique? Did you give them just one device and they had to make a verdict on the one device? And did you trust the opinion of this one single subject, or did you compare the results between multiple subjects for the same data point, let's say?
I could not understand better. Do you mean that the script design, script developing? We recruit the students. Do you mean this?
Yeah. Yes. Could you please explain a little bit more the rules of this experiment and how you set up this experiment?
We recruit the graduate students because many researchers have proved that experienced graduate students can replace the actual industrial app developers to do the work. And our recruited students are very experienced in mobile app testing. So I believe that the scripts developed by them is very representative. And we only record the scripts on one device and replay them on many different devices, because the record phase is very simple, and there are not many technical challenges. We only need to collect the screenshots and collect the actions. And the most challenging part is the replay part. So we did not record the scripts on many different devices.
I see. How do you envision your approach integrating, let's say, in practice? As a software engineer, if I'm developing a new mobile app, how am I supposed to use your tool? Is there an open source project? Is this something that could be integrated into a CI framework or something like this?
Could you explain more about your question?
How do you imagine your tool being used by practitioners in, let's say, industry?
Our tool the tool demo paper has been accepted in 2019, and since then our tool has been adopted in many different industry companies, including different areas like finance companies, like internet companies, and some very important nuclear industry company. So I believe that our tool has been experimented on the real industry scenarios. So the industry application is very smooth.
Excellent. That sounds like a success story for your tool. Yes, well done.
Yeah.
If there are no more questions from the audience, perhaps we could wrap up the Q&A here. Thank you very much, Shen, for your paper and for your nice presentation. The next paper that we're going to have in the session is titled Industry Practice of Coverage-Guided Enterprise-Level DBMS Fuzzing. It's a software engineering in practice track paper, and I will see everyone in roughly 11 minutes for the Q&A for that paper. Thank you very much, Shen again.
Hi, thank you, Jose. Bye.
Bye-bye.